right, the second section here with conic sections. So I guess as far as I guess it would make it the third. I know this is the second section of notes we're doing, but this is the third type of conic section in this unit, because we've already covered parabolas, which was not a new thing to you guys, considering you've all been through Algebra 2. And then we've also done circles, which was also possibly not brand new to you. In this pre-calculus class, I may have mentioned the standard form of an equation that would be graphed as a circle. But now we're going to move on to ellipses. Ellipses are another type of conic section, and they are essentially an oval. I guess if you wanted to get like super technical, you could talk about these focus points in green down here. And an ellipse is basically a collection of points. Let me make sure I say this correctly. So let me go slow here. It's a collection of points that are all equidistant, or like, gosh, this is tough. The sum, let's see. If you take like every point on this ellipse and you take like the distance from, like, let's say this random point right here, okay? In fact, I'll even, to help me out, like, so there's a random point on the ellipse. If you do like the distance from each focus point and you add them up, that's going to be some value. Like this distance plus this distance. That's going to be something. And then you do the same deal for like that dot, and you add up the distances from the two focus points. You're always going to get the same sum. So like this point down here, you add up the distances. So like this distance plus this distance. You're always going to get that same sum. And that's technically what an ellipse is. It's a collection of points that are like that are equidistant, like the sum of the distances to two focus points are always the same. It's a very weird, fancy way, technical way of just calling it an oval. Because anyway, I'm not going to compare it to a circle in that way, so never mind. But anyway, this is actually going to be very, very, very simple, I hope, because again, it's just going to kind of boil down to, we have this certain form, okay? We have this certain, let's just call it, standard form of an equation that gets graphed as an ellipse, okay? So, first of all, we have this h and k value again, where h comma k, what do you think that's going to represent? That's right, the center of the ellipse. So in this basic example, it looks like we're centered at 0, 0. And so, yeah, like h can be 0 and k can be 0, but they don't have to be. Like if you look at this ellipse right here, it looks like we're going like over a certain number and then down a certain number to get to like, a center. Here the center is just at 0, 0. But anyway, more on that as we go. We also have this A value and B value. Over here, let me just get this out of the way. Over here, it has to always equal 1. So that's sort of like a constant sort of staple in the form, in the standard form, equaling 1. But we also have this A value and B value. Okay? So a, now again, notice how this is a squared and this denominator is b squared. But just the a is like the horizontal radius. And b would be like the vertical radius. So again, a would be the horizontal radius of the ellipse, or like the, well, never mind, I'm not going to, I almost sort of goofed on my terminology. So anyway, once again, b would be like the y radius. So a squared always goes under the x part, and b squared always is said to go over under the y part. So b is like the y radius or the vertical radius. A is like the x radius or the horizontal radius. Now, things are going to get a little dicey right now. Okay, so pay attention. In this situation, A is larger. So we would call this right here our major radius. Okay, or we would call this whole thing our major axis. It gets weird, right? But I guess you can always think of your, because over here, our A value would actually be smaller. So sometimes this happens. When your A value is smaller and it's your B value that's larger. But no matter, I mean, so it's not like what's A and what's B depends on what's larger or smaller. A is always with X. But you always call your larger radius your major radius, or like your entire diameter, you can call like your major axis. And your more minor, values, like your minor radius, or like this whole thing right here, would be like your minor axis. So here, this would be your whole minor axis, and this whole thing right here would be your major axis. And this would be like your major radius, which is actually also sometimes called your semi-major axis. Semi-major axis. And like this would be like your semi-minor axis. I know a lot of terminology, but because the graph overall is pretty simple, like this A value and B value and this whole form. It's pretty simple, you know what I mean? And so like over here, this would be like your semi-major axis. I don't know, whatever. And like your major radius. Anyway. So again, the form pretty much isn't that crazy, And those like focus points I mentioned. Just kind of double check here. Yeah, okay. I just didn't want to be wrong. You also have like this c squared equals a squared minus b squared little equation that pretty much just speaks about where those focus points would be, because from the center to the focus point is a distance of c. You know what I mean? Now in this simple example where we're centered at 0, 0, that coordinate right there, the coordinates of that point right there would like literally be c comma 0. And that would be like negative c comma 0. Over here, you could actually say, since again this one looks like it's centered at 0, 0, this one would be 0 comma c and 0 comma negative c. So 0 comma negative c, 0 comma c. Now, obviously the coordinates aren't that simple when you generalize them all the time, because what if you're not centered at 0, 0? The bottom line is, from the center to the focus point is a distance of c. From the center, like, because here, talk about going back to A and B. Here, like, the coordinates of that point right there would, like, literally be A comma 0. But that's only because we're centered at 0, 0. Here, it's a little more complicated, but anywho, that's how you can kind of make connections between the standard form of the ellipse equation and the actual graph. So let's see how this plays out. You know what I mean? Now again, if we're learning, virtually here, I don't know if your homework assignment, I can actually expect you to draw the final graph. But we can at least talk about how, well, what's my center going to be? Does this totally match this standard form? Well, yes, it does. It just turns out that h is 0. Like, this technically says x minus 0 quantity squared. And this technically says y minus 0 quantity squared. So my center here is just 0, 0. And then we can talk about, like, how about we'll put it this way. Our major radius, which we could also call, like, our, I know I don't want to, like, throw too many things in the fire here, but I mean, we could also refer to this as the semi-major axis. But I don't know, this is a much simpler way to say it. Like, it's our major radius, The whole axis would be like double this, and so they call the whole axis like the major axis. And so just the radius would be the semi-major axis, but let's just say the major radius. And the major radius would be, well, I don't know. Again, it's not necessarily A or B. It's not necessarily A. It's the larger one. So in this case, it's going to be our B value is our major radius. So our B value is actually, so let's actually say that B equals 4, because that's B squared. And our minor radius is actually our A value here. Okay? And I suppose we could also do, like, I don't know, c squared equals, remember, c squared is always, a squared minus b squared, or the other way around. So here we got, like, 16 minus 9, which is 7. So c, well, I don't have to say I mean, I guess I could approximate that, but maybe better just to say the square root of 7, which is, I mean, maybe we want to I don't need you to, like, we don't need to, be super, super, super crazy strict on this. I mean, that would be, if you had to, like, sort of sketch where your focus points were, or if you had to identify that. I mean, you could approximate that. I don't care. But so what would this look like? Well, the center would be 0, 0, which, I mean, it's not technically graphed. I guess I could, like, kind of like ghost graph it, just so I know what I'm looking at, you know what I mean? But what color do I want? Let's just stick with this purple. So there's my center. My major radius is actually B, so 1, 2, 3. It's 4 in that direction, and likewise, and then my minor radius is actually my A value. So 3 and 3, and again, so that means my focus points would be on this axis. You know what I mean? like root 7 away from the origin, basically. But there's my oval, my ellipse, okay? And that's basically example 1, done and dusted. Example 2, does this fit standard form perfectly? It does. And so my center would be what? It would be h comma k. So what's my center? What's my h value? My h value is basically 3. And then what's my k value? Isn't my k value -1? Because remember, as I've said a couple times in the past at least, there are negatives built in to the form. So, you know, what this basically says is y minus a -1, you know. So here, my major radius, looks like this time it's a. So if that's a squared, then a is really just 5. And then my minor radius, this time is my b value. And if b squared is 4, that means b is 2. And then if I wanted to talk about c, let me actually just adjust this formula. If c squared equals the square root of a squared minus, or I'm getting ahead of myself. If c squared equals a squared minus b squared, then just c would be equal to the square root of a squared minus b squared. So that would be the square root of, let's see, 25 minus 4 is 21. So that would be like my c value, the distance from the origin that the two focus points would be. Anyway, to sketch this graph, see once again, the center is not technically 3, -1, so just kind of, and then my major radius is 5, 1, 2, 3, 4, 5, so kind of little, just kind of spacing this out, 1, 2, 3, 4, 5, and then 2 and 2, okay, and that would be a basic, oh god, not great, but that would be a sketch of my ellipse. Easy peasy. Easy peasy. Number 3, hopefully is also easy enough for us. Do you think this fits standard form here? X minus something quantity squared all over something squared plus y minus something quantity squared all over something squared equals 1? It does. So what would be our center? What's my h? Isn't it technically 0? Because that's like x minus 0. And then what's my k? Looks like my k is -6. So 0, -6. Now what's my, let me go off script a little bit. What's my a value? Well, if that's a squared, then my a value is 4. What's my b value? What's b squared? Like, isn't this really all over 1? Yeah, like you could think of this whole y plus 6 quantity squared as just all being over 1. So if b squared is 1, then b is 1. So I hope that makes clear, perfect sense to you, because I'm moving on, okay? So it looks like now my major radius will be an a value, not instead of the b value, rather than the b value, whatever. And so a equals 4, and then my minor radius will probably b equals 1. And then it looks like c squared will equal 16 minus 1. And so c is going to equal the square root of 15 if you ever had to graph it or talk about where the focus points were. So my center is 0, negative 6. 1, 2, 3, 4, 5, 6. Major radius is going right and left. 1, 2, 3, 4. 1, 2, 3, 4. And then just 1 and 1. And so, oh God, not half bad. So there's number 3, and we got one more, and you knew I just had to make things a little more interesting. Why? What makes this a little different? Well, hopefully it's obvious enough that it is not looking to be in that standard form. It is just not. Oh man. So, I mean, look at this. I got this minus 16x, you know. At least here, you could be like, okay, I mean, I don't know. I mean, that 9 really can't be there. You know, you might be thinking that my k value is 0, but, you know, that 9 really can't be there. And this is all supposed to equal 1, not 20. But, oh my gosh, this minus 16x term. So guess what, people? We're going to have to complete the square. You know, because I want to have like a bubble squared. Now, once again, this 4 can't really be there either for like final standard form. So here's what I'm going to do. I'm going to factor out, oh, idiot. So I'm going to factor out a 4. And so now this is just looking like x squared minus 4x. We're getting a little closer to something that could be rewritten like this. You know, just x minus h quantity squared. But what we have to do here is we have to complete this square. So just what's in the bubble here, what could we add as like a third term that would make it a perfect square trinomial that would unfoil into the same two bubbles and therefore would be a bubble squared? Remember the shortcut? Cut this second term in half, or at least the coefficient anyway. Cut it in half and then square it. So half of negative 4 is negative 2, and then when you square it, it's, you know, plus 4. Now, something worth noting, big time. I'm adding 4 to this bubble. You know what I mean? I'm adding 4 in here. I got to balance things out by like doing the same thing to both sides. But what am I really doing to this whole left side? If I'm adding 4 to like the inner workings of this bubble, since there's a 4 out here, aren't I really adding 16 to the entire left side? Because anything in this bubble is going to essentially get multiplied by 4. So I actually have to add 16 to the other side to balance this out. You know what I mean? So, and then now that this bubble is going to say x squared minus 4x plus 4, remember, why did I do that in the first place? Because now this unfoils into x minus 2 times x minus 2. Or, the way we want to write it, x minus 2 quantity squared. Okay. Now I'm still not good because this isn't allowed to say 36. It's really just supposed to say 1. Well, now it comes the time to divide both sides by 36. And so this will become a 1 like we want it. And over on the left side, I hit the, I'm pretty sure I clicked on purple again. So over here, we actually have two separate terms separated by the plus sign. So this term gets divided by 36. And when we do that, the 4 and the 36 cancels. And we have x minus 2 squared. What am I doing? Do I have room? I guess I have room. I have room. So x minus 2 squared all over 9. Because 4 over 36 reduces to like 1 over 9. When I divide this 9y squared by 36, the 9 and the 36 reduce or cancel with each other. And I have just y squared over 4. Okay? So now it's finally in the standard form I want, where I can now identify that the center is 2, 0. And that, gosh, we keep having like this horizontal sort of larger axis thing. So it looks like my major radius is going to be my x radius again. And that's going to be 3, and then my b value is 2. So here we go. Center at 2, 0. And so there's 1. So there's the center. And then 2 and 2. And I could, easily find my c value for my focus points if I needed to. But that's how we do that. So I think that's all the examples I'll do for now.